Okay, good morning everyone. Welcome to another sessions of our very fun and exciting AI class. Okay, today I'll be moving to another topic that I've been helping a lot of students lately, I guess for a while now, which is time series. Because most of your project, you might probably gonna encounter the data that depends on time. And when you deal with time-based data, there's little things that you need to take care of. And in most cases, if you use sklearn, which is a library that we used before, it's quite cumbersome in a way that you need to take care of many little things that can, it's very easy to make mistakes when you're dealing with time series data. So that's why today I'm introducing another library that's creating for this specific purpose, which is time series data. Okay, and we're mostly going to be focusing on time series forecasting. But I just want to let you know right off the bat that when you use time series data, forecasting is just only one of many things that you can do. Let me show you this one. Okay. Actually, I'm going to show you another library called Eon, but I'm not using this one right now because this one is focusing more on other things apart from forecasting. The library that I want you to use in this class is called skTime. So let me just make sure that we're on the right page here. Okay, skTime. Okay, this guy right here. So it's like scikit-learn, but with a time series, so it's called skTime. So this one, I'm going to use it mostly for forecasting, which is, I think, a lot of you will probably going to encounter, I guess, in your project or in the future. This one, very good, very stable, okay. But actually, at the moment, I'm actually exploring another type of time series activity. And this library is the one that I've been looking at and enjoying it lately. So this is called Eon. I just want to let you know that for Eon, you can actually do something apart from the forecasting, which is called time series classification. You can also, when you say about time series classification, it's like if you have the data that become time series, but you want to predict something that's class, like this time series, maybe you can think about like maybe if you in the medical field and then you read the EKG graph, like the heartbeat or something, and you want to know if that graph is for the patient with disease or not. The answer that you want is actually class, not the number. So that's something that you would do for time series classification. And this is something that I've been interested in a lot due to the project that I've been going on. But then there are other things that you can do with time series apart from just forecasting. So I just want to let you know that this one is actually quite very advanced and very cool if you're into the time series and you need something else rather than just forecasting. Okay? But today and in our class, we're going to do this one for forecasting. Okay? All right, so let's dive into the world of time series, shall we? So I'm going to use the S01, and then I'm going to go to the data, the C1 topic, okay? And again, I'm going to just type it in just to show you this way, okay? All right, so first thing I want to download some of the packages for a function. Okay. So as you might take a notice here, it's from skTime. So you gotta have this library installed, okay? And I'm loading something from Panda because that's behind the scene. The data is written in data frame format, okay? So first, I wanna explore the toy data that I guess that the library has for me, which is called airline data. So the library provides me with a function that I can use to load data. So it's called load airline. So let's see what it looks like. Oh, I guess I have to wait for this to load. Okay, just hold on for a second. Okay, the first time usually takes, it's done, okay? So first thing, I want to load the data. It's called load airline, okay? So let's see what it looks like, okay? As you might notice that this one, let me just put it into y, okay, the variable y, okay? I want to check what type this variable is. So I want to go to terminal, right? And I want to go to Jupyter. So I want to check what it is, okay? So this is series, okay? Series is a data type in Panda library, okay? In Panda, you have data frame, which is the two-dimensional data, and series is just one-dimensional data with the index, okay? So when you have series, you're going to have the data itself, which is the number on the right column. But again, you also have the index that come with it, and this one is particularly useful because when you have time series data, each row has to have some time associating with it, right? And usually you wanna do it so that it's occurring in time, right? It's consecutive in time too, okay? Let me just show you what the index is, okay? So I want to do y.index, okay? And maybe I'll just show you the value itself. So values, okay? Okay, as you're going to see that actually the value also has a very specific meaning, okay? You can see it's called period, okay? Let me show you if I just pick one of them. So I just pick one value from that array, okay? What is it? Okay, as you can see that this one is actually a period, and M is called the month. Okay, so so right off the bat, the way that we would store time series in our variable is actually quite special, right? We don't just type the time, like if you do like this, it's just a string like 1949:01, right? That is a string, right? This is something that you would do in your Excel, right? You would just type the month, for example, right? But then when we store things in Python, a better way is to actually store things in something called period. Period is another variable type that specifies the period of the whole month. And the useful thing when you do something like this is that this is not a string. I mean, it also contains a string, but it can do more things. Like you can transform periods into day. You can ask for durations. You can do the aggregation of the periods and things like that. I'll show you a little bit later. But as you can see that right off the bat, this is a much better way to store the length in time in your data rather than just a string like this, okay? Okay, I'm way ahead of what I want to show you, but I just want to, I thought it would be something that I want to mention first, okay? Okay, so right off the bat, I wanna plot this. Okay, usually when you have time series data, plotting things is a bit more challenging. Okay, but in SK time, that's something that we have to do always. So it provides an easy to use function. So plot series and y. And that's it. So whenever you have the data that is written in series, and then your index is like a period, not just a string, then the function plot series is pretty useful. It's pretty smart when you use them to plot. So once you format your data in a certain way, it works really well with visualizations in this library too. Okay, like that. So right off the bat, you can see that this is the airline data and the number of airline passenger. Okay, so how did it know to put this in here, right? Like, where is this from, right? The X label, like the Y label, okay? It's actually written in your series, Y. You see this one, name, okay? So that's kind of useful, right? When you have your data and you can specify the name in the series, and then when you plot it, it comes here right away, right? That's something kind of convenient about using this kind of functions, okay? Okay. But that's the data, okay? So next off, I want to show you what the period is, right? Again, I do y.index, right? Okay, index, okay? That gives me the whole index, right? But then I want to check the value. I want to output it in terms of the array, right? This one become array. But then I just want to get one thing, which is the first one. So that's the index of the first row, okay? Okay, so what is this, right? I want to do this IP, okay, equal y.index.value. Okay, I just want to store it in a variable somewhere called IP, okay? Then what can I do? IP is actually a class instance, so you can do dir. So dir meaning that I just want to see what attributes and methods it has. It actually has a lot of things, but you can see that something that relates to time because it's the period in time. Okay, for example, I can do something like this, right? IP dot year. Then can appear right here. See, so this variable is called the index, right? It's the period time index period, right? It's actually knows what year it is, right? It's actually know what month it is. It's a January, so maybe, yeah, January, right? It also know what day it is, 31st, okay? It's actually know even the hour, right? 0, okay? Because when you're dealing with the monthly period, the hour doesn't really matter, so it's default to 0, right? You can do minutes, right? And seconds and things like that. So it's minute with no s, right? So something like this right off the bat, like with just one index, you actually store a lot of things that you can use at your convenience later on if you want to transform your data into something more like maybe more granulated later, okay? And again, yeah, I can just print the whole thing, right? This is something that I wrote here, like that, okay? So this is, again, this is not a specific point in time, okay? This is the whole month. Like this variable specifying the duration starting from here. This is the starting point, okay? Okay, so you might be wondering, okay, that, I mean, fine, we have the data like this from the toy data, right? But what if we have the data from Excel? Like how do we convert this data into something that the library can work with, right? And that's the whole purpose of this one, okay? As you can see, I have another file called electric.csv, and that is just a text, right? And again, you can see that this is something that you would do in a spreadsheet, for example, right? You would just specify the value, like the dates in here, just a string like that, right? But actually what you want from here, this is not a point in time, right? What you want is actually the whole day. Like the first row is actually some value for the whole day. So when you write it like this, in your mind, you have to think about, this is not a point in time, this is the duration, the whole day. It has 72 point whatever value, right? And then another whole day. So that's the point about converting all of this into the duration. But this one doesn't contain that information. So I'm going to show you how to do it, okay? So first, I want to read it into Panda data frame. So I want to do something like this, pd.read_csv, right? And then followed by electric.csv. I think that's what I want. Yeah, I got the data. But again, if I were to, I just put it in df1, okay? Okay, but if I were to look at this, right, I should do df1.info. Maybe not info, but I want to do df1.head. I want to check the column. So the column is called date, right? I want to do df1 and then do the date. Just want to pick that columns, right? And then I want to do values. I want to see what the value is, right? As you can see, this one is just simple strings. It doesn't really contain any time information. It's just a string. So what I want to do, I want to convert all of this into time, like the actual time information. Okay, so the way that we can do is actually, there's a function in Panda called pd.toDateTime, and I can put the whole things in here. So I want to put the whole column that has a string, but that one should be converted into the time information, like that. Okay. See, right now, if you can kind of look into the type, it's called datetime64. Okay. So date time is actually a point in time, but it's in Python, I guess Python data type. So this one has more meaning now. This one, you can actually extract like the day, the month, and year from it, and you can do a lot of cool things from it. But then this one is actually still not the period. This one is just a point in time. So this is not what we want yet. Okay, so I gotta convert this one into the period in time. Okay, so that's the whole point of this one right here. Maybe I'll just type it to you. Okay, so it's called PD, okay, dot date time index. Okay, so date time index. Okay, and then I want to convert again the whole date, right? I don't want to convert into date time yet, but I want to convert into the date time index, right? And then I want to do to period, another one, and then month. What? Something wrong. Oh, the capital T. That's why. Okay. Okay. So the way that I do this is a little bit different from what I just showed you. Okay. What I just showed you above, I just convert the string into a point in time, and that's fine for other operations. But for the time series, I think it makes more sense to convert them into period. So that's the whole thing about the period, okay? And you can see that the data type is now period. Okay, so that's what we want, okay? I know that it's a little bit convoluted and complicated, but I just want to mention it now because if you're going to do this, this is all you need. You don't need to do anything else more than this. You just kind of use the code, okay? So just be aware that the best practice when you deal with time series is to use the period as your time index, okay? All right, so once we do this, I wanna store this back into df1, right? So I gotta do df1, right? And then the date column, I wanna transform it into the period, okay? So right now, if I do df1 again, it looks the same, but now let me make sure that I run the whole thing, right? Okay. But now I think df1 date should have something that, yeah, it become period now, okay? And once you do this, then you can, also another thing is that if I do df1 at this moment, right, it's still, I mean, date is it's another column, right? You have column called date and values, but then you also have another column called the index column. This is row index. This one is not useful in time series. Usually what we want is we want the index itself to be the time. So that's the whole point of the last code, which is called set index. So the one right here. So I want to set it so that the data frame has the index in time. So that's the most appropriate data to be used in the library, okay? So I'm going to do df1.setIndex, okay? And then followed by the column date, okay? There you go. So again, this is what we want, okay? We want the data that has time index as the period, and then whatever values we want, okay? This is the one that we want, okay? So once we get this data into the correct format, then the rest is pretty easy. You can just do plot series and then df1. There you go. And just for a kick, as you remember, I was telling you that if you set the name correctly, then this one actually will be the X, the Y label for you. So why don't we do that? I didn't have it in my code, but you can include it in, right? I can do df1.name equal plot of blah, blah, blah. Okay, like that. What? Hold on. Oh, wait, I thought it works. It doesn't work? Oh, you know what? I know why. This one is actually data frame. This is not times. This is not series. So One more thing. If you want to be exactly like the example, you gotta do series, not data frame. Okay, so let me show you. Okay, it's let's see, so SR1 equal DF1. I wanna extract the values out like that. Okay, so this one is series. If I show you, if I look at this, you can see that this is a series. This one is a data frame. Okay, different. Okay, and this one has the name called value. So I want to set sr1.name equal plot of blah, blah, blah. Okay. And then if I were to plot this series, then yeah, I got it. Okay, so something I want to mention, right? So if you have data frame, then it looks for, I guess, the name of the columns. But then if you plot series, then it looks for the name of the series itself. Okay, so I mean, I guess if I want to do the same thing, but with df1, then maybe I gotta change my column name. For example, I can do something like this too. Sorry, I might go a bit wandering this too far, but like I can do df1, right? Dot rename. I want to rename columns. Okay. I mean, this one might be better. Columns. Okay. Equal, right? And this one I give them the dictionary, which is whatever the column I have in the first place, which is value. And I want to do something else like plot of values, right? If I do that, then my column is actually changing. Okay. And then I should be able to plot them, and then it shows in my, I guess in my graph, in my Y label. Okay, head. Okay, like, wait, no? DFT1, okay, sorry. DFT1, my cursor is messed up. Okay, DFT1 dot head. Okay, let me run it again. There you go, I get plot of values. And then I can do something like this, plot series. Okay, and then do DFT1, like this, then you got it. So the nice thing about using a data frame is that actually you can even have more than one columns too. Okay, maybe I'll just show this right away. DFT. Maybe I have another column called values 2, like value 2. Okay, equal, I don't know. I just pick one number, maybe 50. That's it. Okay, DFT1. Sorry. Okay, and if I were to plot DFT1 again. Input must be unique. Okay. It doesn't allow me to do okay. Doesn't work like that. I guess I gotta do something like this. Values 2, and then DFT1 plot of value. Yeah, I gotta do two series. And wait, not. Okay, never mind. This one I don't want to be debugging for you. Okay, right now. Sorry. I wandered too far, but whatever I show you, I think it should be enough. For most of it in the examples of the class, okay? All right, so that's the data type that we might be looking at when you deal with time series, okay? Next stuff, I want you to kind of play around with the data a little bit. Essentially, just look at the data, right? Like I was telling you, right? If you have data, you might want to see, like, explore the data, and this thing we can do them using skTime library. Okay, so c2.ipynb. Okay, again, I want to import similar things from sklearn, skTime. Okay, so first thing I want to load the data. So load airline. Okay. And this one I want to output into Y, okay? And again, I can do plot series of Y. Pretty easy. Wait, I need to run it. Yes. There you go, okay. In my code, you might see that I have another line. I have another line that says plt.show, right? Actually, this one is optional, but it's kind of nice because if you don't do this, then you're going to have this thing here, which I think is kind of annoying. Like, it kind of print out this kind of information, right? I don't want it to print, so I just want a plt.show. That's all, just to kind of get rid of that little information. So, okay, and what you can do right away is actually Y, right? This y is your data, right? You can do y.diff, okay? This one is quite useful in terms of looking at your data. When you do .diff, that means that you are taking the difference between your current row and the row that is below it. So the difference between row, okay? Why you would want to do this? Let me show you this one, okay? So I'll do plot series, right? First, I want to do y.diff, just the first one. I got the y.diff, okay? So as you can see that if you were to take the difference between the point and the point adjacent to it, then this is the difference, right? What this one shows you is actually the stationary version of your data, right? As you can see that this one has trend, right? It kind of goes up like that, right? When you do the time series forecasting, for example, what you want the model is actually two things. Trend is like this, it goes up, that's a trend. But then you want to model the growth in your, I guess, fluctuations. And when you can kind of see these two things separately, it's kind of nice because you can kind of tune your model. For example, ARIMA, it will ask you to do trend, you seasonality. This one is seasonality. And if you can see that your data has some season to it, like this, it might have, you know, like a year or something, then that's the information that you can input into your model. So seeing your difference in your data is actually quite useful in choosing your model, okay? And I can also do the second difference, so diff and then diff again, like this, okay? So usually when you do something like this, it's when you want to see if your data, what order of difference is still giving you some seasonality. So that's something that you can input into your order in your ARIMA model. So I mean, that's kind of statistic things, but I just want to let you know that people look at this generally, just take a quick look at it, okay? For no reason, you can just take a quick look too, okay? And it doesn't cost you anything. It's pretty easy to do, okay? So then y.describe, it's another thing that you can take a quick look at, right? Okay. Again, this one, it's built into Panda data, Panda library. The count, it's the number of points, right? Mean, right? Pretty self-explanatory. Standard deviation, min, max, and then the quartiles of your data. Okay. So just take a quick look to see if it's it looks normal. Okay. Okay, so here's the thing. I want to do this one is a little bit kind of window length. Okay, so let me show you this one. Okay, so I want to do some rolling mean, which means that I want to take, maybe this one is too noisy. Maybe I want to transform this data into something smoother. That's called rolling mean, meaning that you take the windows and then you take the average of it, and then you kind of keep moving the windows. Okay. So first, I want to define window length, okay, equal 12, all right? And then I can do something like this, y.rolling, okay, and then give them the window length, okay, right? So y.rolling will give you kind of like the results of it. But this result is actually, it's not done yet because you have to tell them, like, what do you want to do within that window? Okay, so I want to take the mean of it, so I dot mean, like that, okay? So now, what's happening? Let me just show you how it looks like first, okay? So I'm going to do plot series, okay? And then that whole thing. So maybe I'll just take it into that yt equal that one. And then just do yt. There you go. So as you might imagine, like this process is to take, go back to your original data, because my window is 12, right? So that means that I'm going to take the first 12 dots and then take the mean of it, and that is the representative value of whatever the last dot is, okay? So as you can imagine, if I were to plot them, this one, okay, if I were to show you this one, you can see that the first 11 row is actually NaN. See this? And that's because your first 11 row, it doesn't, I mean, the mean is not complete yet. You gotta have 12 rows, right? And then you take the mean of that, and then you put it into the 12th row. And then for the and then you move that window, so you go from like the second dot to the 13th dot. You take the mean of that, and that become another value. And then you move the windows and take the mean, and that's how and that's called rolling. When you say rolling, you gotta have some window of something, and it keep moving like that. Okay. So this kind of operation, if you have to do that in other software, it's pretty hard, right? If you have to, like, even though, like, imagine doing this in Excel, like, I don't know, it's pretty hard to do, right? But usually in Panda, it's extremely easy, okay? So we have mean, right? We can have other things like maximum. I don't know if that's useful, but why not, right? Max. There you go. So that is a maximum between, like within the rolling windows of 12 dots, okay? And you know, you have max, and why don't you do min, right? There's no reason to do that, right? And why don't you do standard deviation, STD? There you go. See, there's a lot of things that you can extract from your data, and the rolling operation is particularly useful, okay? And I mean, and not even this one, you can actually input custom value into it, like your own function, like to do whatever you want within that window, okay? And the concept of rolling will come back, and that's the thing that's quite that's quite annoying when you have to deal with the time series. It's called the rolling forecast, okay? Okay, all right. Before I go too much, I wanna. Oh, okay. Actually, I can do label. Yeah, I forgot that. Okay. So I can do, when I plot it, I want to plot with the original data, right? So maybe I'll just do this one. It's actually easier. Okay. I want to do, y, and then I want to do label equal, right? Original, and then I want to do mean. Okay, like that. This one, go back to mean. There you go. Wait, what? It's not working. Why? Label, okay, label with S, yes. Okay, there you go. Yeah, I should have plotted this one for you, sorry. So this one tells you that, you know, the mean start from the 13th, I guess the 12th row, because you don't have enough information here to calculate the mean of the row of the windows, okay. Okay, what else do I have? The next I want to do, I guess, yeah, let's do the other one. So this one is a little bit complicated, but I want to show you, I guess, the another cool things I can do here. Okay, I gotta do y2. What is y2? Oh, I need to copy it. Okay, sorry. So I copy it because I'm gonna change it. Okay, so I copy. I guess I never mentioned this, but when you set y equal to y like this, like this, it's actually not creating a new data. Like when you do this assignment, it means that these two things is the same. If I were to change this one in any way, this one will get changed. So I don't want to change my original data. So that's why I do y.copy, so that it's creating a new like a new data for y2, because I'm actually changing something here. That's why. Okay. So I want to do y.copy. Okay. And I think I do like a rolling things. Wait, not right. Oh, I have to convert. Okay, so little things again. Sorry, kind of like I need to convert the period into I guess the actual points in time for this operation to work. Okay, so y2 dot index. Okay, I'm actually turning it back into just a normal time, point in time. Okay, to index. Okay, to timestamp. So this one convert the range into just the point in time for these operations. Okay, and I don't need that. Okay, and there you go. Okay, so I mean, I guess this one is kind of complicated looking code, but you can see the results, right? I can do, you know, I can do some cool plot to it, which is calculating the mean and also the standard deviation and plot them in an interval. Okay, So you probably don't have to do this, but I just want to show you that's like, if you want to do like a more complicated plot, this is something that you probably going to be looking at, but probably not in this class, okay? Okay, next thing is called auto correlations, okay? So this one kind of delve into the statistic of your time series a little bit, okay? Okay, so what does auto correlation means, okay? So auto means itself, okay? Doesn't mean automatic, it means itself. So correlation is how the data kind of goes up and down together. Like that's correlation, right? So autocorrelation is how the data is moving up and down with itself. Because when you have time series, usually the data in the future is influenced by the data in the past. So there is usually some correlation between the data of yourself. So that's why autocorrelation is something that people in time series looks at, okay, to see if your data doesn't have any correlation with yourself in the past. That means that you cannot build any model to describe it. To describe the future forecasting, you need the data to have auto correlation with the past. Okay, so that's why people look at auto correlation. The data that doesn't have any correlation with itself in the past is the random data. If you just put random noise, that data has no auto correlation. Okay, so that's why we look at such data like that. That's this one. Okay, so in order to do that, I'm just going to show you, just copy the code because it's probably not something you would look at in this class, but it's kind of nice to look at the results anyway. Okay, so what I show you is actually the lag. So lag, it means that what is the point of yourself and then plot against the points that are in the past in a certain lag, meaning like go back like number of points. For example, lag of 1 is just the point next to you in the past, just the point to the left maybe, okay? But if you, and again for 3, number 3 is the plot of the current, right? And then the point go to the past 3 points to the past, and 10 and 30 and so on, okay? So if you look at the lag plot, you can see that, yeah, this data actually correlates with one itself. As you can kind of see that it has, peaks and troughs in a period like, so that type of data actually has auto correlation, okay? If the data looks kind of flat, that means that your data doesn't correlate with itself. So that means that it probably wouldn't work as well to do forecasting, okay? And there's also another way that you can measure correlation. This is something called the ACF function, okay? This one, okay? And I'm going to show you the plot right away, okay? Okay, it's called the plot ACF, okay? So again, this is the plot that you might encounter if you were to go deep into like a forecasting model in statistics. So autocorrelation, and then this one is the lag. It means that whatever the current point is, what's the correlation between the point in the past? And usually the correlation is high for the point that are next to you, because usually the most recent point influence the point at the current time, right? And then back to the past, it usually has less correlation, right? Because the wave in the past, it usually have small correlation to the one in the current period, right? But that's not always the case, right? Usually if you have some type of a seasonality, you can detect something in here. For example, if you go back to our data, you can see that it actually has as a peak every probably 12 points, because this is the airline passenger. Usually it peaks around the Christmas period, right? So, and if you look at the correlation in here, you're going to see that it's actually kind of go up at around the 12 peaks, right? Because it's the seasonality. So that's how people detect seasonality and input that into model like ARIMA. Like, because in ARIMA, you can do like seasonality and it has the ordered. So you can do like 12 because you know that your data actually has high correlation with the period of 1 year, of a year, okay? And also, if you have the 12, right, and it will have another correlation at the next year because your data at the current time correlates well with the data at the same month in last year and then the 2 years previously. So that's how the correlation works. Okay, so that's kind of a nice thing to know. You know, look at your data. If you don't see correlation at all, then you are pretty hopeless against building any type of model. Like even machine learning doesn't work. You got to have some correlation. Okay. Okay, so I just want to mention that this one I imported from another model called stats model. So this one it's a quite popular model in Python if you want to go into deep dive into statistics. I'm not going to go deep into here because I don't know very much about it. I never use it that much. I only use it to plot something like this. Okay, and I can also plot autocorrelations using pandas. So let me show you. There are many ways to do. I think it might just look the same. Yeah, I actually know. Okay. Oh, but this one I plot with the difference. So maybe I can just back it off. Yeah, it looks the same, right? Looks similar. It's just different way to plot it. So right now I don't know why I put the diff. Okay, but I want to do the plot itself. Oh, I do it here. I comment it out. Okay, so if I do the correlation of the original data, I can also do the correlation of the difference of the data. Okay, so this is the example, right? If you take the difference of it, then the data has pretty much no correlation with one another. So I mean, but that doesn't. It just means that I guess your correlations kind of contain into the original data. That's all. That doesn't mean anything much. Okay. All right. So another thing that I want to show is partial autocorrelations. Okay. So this one is it's a bit complicated. I think I have links for you to explain. Wikipedia, yes. Okay. It's the association between random variables. So that's something correlation also means. But then it's the I guess it's the effect of controlling random variable removed. So what I kind of get from this is that, like, if you do correlation, it has indirect effects too. Like when you do when you want to measure correlation with the data in the past, there's an effect of like the direct correlation between it, and then there's an indirect correlation. So indirect correlation is like if you correlate with other point, and that point correlate with your target point. So it kind of do many hops before it goes into the target one. Direct one is like yourself and the target. So when you do partial correlation, it's removing all that indirect hop, and you just measure how, like, what is the correlation between the point of interest and the target points. Okay. It will probably not gonna be matter that much in your case, but I just want to let you know that people actually look at correlation and partial autocorrelation. I guess both of them just to see, you know, what's the correlation of your data is. Okay, and again, I can just use the stats model to do it, like that. Okay, and then I'm going to do the plotting, which is this one. Okay, so it's plot PACF. There you go. See, as you can see that if you look at the partial autocorrelation, it's much less than what you would see from the correlation itself, because it's like removing all the all the indirect hops, just yourself and whatever lag point that you are interested in, right? But again, you're gonna see the same thing. It's gonna kind of goes up at about the 12th point, which is like yourself and, you know, like last year, and then another one probably at the 2 years. But the effect's actually less. Okay. This one also something that you can use when selecting the parameter from the ARIMA model. So I might come back here in the future when we talked about that type of model. Okay. But yeah, so like you can kind of use this code to explore your data right away. So yeah, so I encourage you, if you have like, you know, time series data, use this one, this type of analysis to get to know your data more.